You're picturing this wrong. You think a black hole is a place, some dark pit way out there that you'd have to go looking for. Point a telescope, squint hard enough, eventually there it is. No, that's not how this works. And once I show you why, you're going to look at the night sky a little differently. Here's the first problem, and it's a real problem, not a trick question. A black hole gives off nothing. No light, no glow, no signal of any kind escapes it. That's not a limitation of our instruments. That's the actual definition of the thing. So the moment you say, let's go find a black hole, you've already asked for something almost logically strange. You're asking, how do I see something whose entire defining property is that it cannot be seen? Think about that for a second. Everything else we've ever discovered in science, every particle, every planet, every distant galaxy, we've found because it did something. It glowed, it wobbled, it left a track in a cloud chamber. Science is, at its core, the study of things that leave evidence of themselves. But a black hole, alone in the dark, doing nothing, touching nothing, it leaves no such evidence. It's not hiding, it's just absent, cleanly, perfectly absent. So right away you should feel a little uneasy, because we're not hunting the object anymore. We're hunting the hole where the object should be. Now here's where it gets interesting, because nothing in this universe is ever really alone. That's the whole trick, and it's a beautiful one once you see it. A black hole might not emit light, but it still has mass. And mass still does the one thing mass always does. It pulls. Gravity doesn't care whether you can see the thing making it. Gravity works in the dark just fine. So if a black hole has a companion, another star nearby, still burning, still visible, that star will do something very strange. It'll move like it's dancing with a partner nobody else can see. Astronomers watch a star's motion, and it curves, it swings, it follows a perfect elliptical orbit, exactly the kind of motion you'd expect from Kepler's laws. Except there's nothing at the other end of that orbit, nothing you can photograph, just empty space doing the pulling. Imagine watching someone waltz across a dance floor, arms out, spinning in perfect rhythm, and their partner is invisible. You don't need to see the partner to know they're there. The dancer's motion tells you everything. That's a black hole in a binary system. The visible star is the dancer. The black hole is the partner nobody can see, but everybody can infer. That's trick number one, the wobble. Here's trick number two, and this one's even stranger, because it involves light itself bending around something you can't see. Einstein figured this out. Mass warps space, and light, when it passes near enough to a massive object, follows the curve of that warped space, bends around it, which means if a black hole happens to drift directly between us and some distant star, that star's light gets bent and focused, like a lens, and for a few days or weeks, that star appears to brighten. Then it fades back to normal. No visible cause, just a flicker in exactly the shape gravity predicts, and then gone. That's called gravitational microlensing, and it means, get this, you could catch a black hole not by seeing it, but by watching something else flicker because it passed by. And the third trick, this one's more violent. If a black hole is close enough to a companion star to actually pull gas off of it, that gas doesn't fall in quietly. It spirals down faster and faster, heating up through pure friction to millions of degrees, and at that temperature, it screams out X-rays. Some of the brightest X-ray sources in our galaxy are exactly this, the last blazing shout of matter on its way into permanent silence. So now you've got three tools, the wobble, the lens, the scream of infalling gas. You'd think, okay, we've got this figured out, we can find them. Here's where I have to be honest with you, because this is the part that keeps me up at night, a little. All three of those tricks depend on the black hole doing something with something else. The wobble needs a companion star. The lens needs a lucky 1 in a million alignment with something behind it. The X-rays need it to be actively feeding, tearing gas off a neighbor. But what about a black hole that has none of that? No companion, no alignment, not feeding on anything, just drifting, alone, through the vast empty dark between the stars, minding its own business. That black hole is completely invisible, not hard to find, impossible, with anything we currently have. It leaves no wobble because there's nothing nearby to wobble. It leaves no lens flare unless it happens to cross exactly the right line of sight at exactly the right moment, which is astronomically, literally, unlikely. It leaves no X-rays because there's nothing falling into it to scream on the way down. It's just out there, a hole in the universe with no edges you can draw. And here's the number that should genuinely unsettle you. Our galaxy is old, roughly 13 billion years old. And massive stars, the kind that end their lives as black holes, burn out fast in a few million years, which is nothing on a cosmic clock. That means our galaxy has had time to make a lot of black holes. Current estimates put the number somewhere between 10 million and a billion, scattered throughout the Milky Way. We have confirmed a few dozen. Sit with that gap for a second. Not because it's rare, because it's quiet. The overwhelming majority of black holes in our own galaxy are sitting out there right now, isolated, unfed, undetected, simply because they're not doing anything that our current tricks can catch. We haven't ruled them out. We've barely scratched the surface of finding them. So, could one be close? Genuinely close? Not somewhere in the galaxy close, but close in a way that would make you sit up. Let's do the actual math carefully, the way you should always do it before you let yourself get scared or excited. If there are on the order of 100 million isolated black holes spread through a galaxy roughly 100,000 light years across, and you do the density calculation, the average spacing between them comes out to something on the order of tens of light years. Some estimates suggest the nearest isolated black hole could plausibly be within just a few hundred light years of us. Some rougher estimates push that number even lower. Now, I want to be very careful here because this is exactly the point where people get sloppy, and I don't want to be sloppy with you. I am not telling you there's a black hole sitting next to the sun. Nobody has found one. Nobody has confirmed one within any dramatically close range. What I'm telling you is that the statistics, the sheer population numbers, say there almost certainly should be one closer than most people would feel comfortable imagining. And we simply don't yet have a tool sensitive enough to search that nearby volume of space and rule it out with confidence. That's not fear-mongering. That's just what the numbers say when you follow them honestly. There's a difference between this is definitely true and this is what the evidence forces us to consider. And a huge amount of good science lives in that second category, uncomfortably, waiting for better instruments to settle it. And here's the thing that I think people miss entirely, the thing that actually matters more than the fear of it. A black hole isn't a monster. It's not lurking. It's not hunting. It's not waiting to do anything to you. It's a corpse. It's the leftover core of a star that lived, fused hydrogen into heavier elements for millions of years, and then collapsed under its own weight when it ran out of fuel to hold itself up. Every black hole out there is a gravestone, a very small, very dense, very quiet gravestone for something that used to shine. So if we ever found one nearby, really nearby, it wouldn't be a threat story, it would be an archaeology story. We'd be looking at the remains of a star that finished its life and collapsed long before our solar system even formed. A fossil sitting in our stellar neighborhood the entire time, present at every sunrise you've ever seen, and utterly unknown to us, not because it hid, but because we never developed the eyes for it. And that, to me, is the real punch of this whole thing. We've built telescopes that can see galaxies from billions of light years away, light that left its source before our planet even existed. And yet something could be sitting a few dozen light years from where you are right now, and we'd have no way to know. We spend so much of our energy scanning the sky for things that shine. But some of the most consequential objects in this universe are defined by the exact opposite, by their total structural refusal to be seen. And I think that should change how you think about empty space a little. Empty isn't empty. Empty is just the label we give to places where our tools go quiet. Maybe that's true of more than just black holes. Maybe the most important things near us, in the universe, in anything, are sometimes the ones that decline to announce themselves, the ones you only ever find because the math insists they must be there, long before your eyes ever catch up. So the next time you look up at a clear patch of sky, nothing there, no stars, just black. Don't assume it's empty. It might just be very, very good at not being found.